In this video, we are going to discuss about classes, objects, instance variables, methods, and method overloading. Let's look at classes. A class can be defined in different ways. Let's see different views of what is a class. A class is a blueprint or prototype that defines variables and methods common to all objects of certain kind. Or in another way we can say a class is a collection of different objects or a similar kind of objects. In another view, a class can be thought of a user defined data type and objects are the variables of that data type. All these objects, they have their own unique copy of instance variables and behaviors, or I can say methods. To declare class in Java, we have to use the keyword called class. Okay, class is the keyword to define class in Java. So to define the class, we have to write class followed by the name of the class. Within the open closed curly braces, we are going to declare variables as well as methods. This is how we declare classes in Java. Here is the simple program where illustrate the declaration of class in Java. Okay. In fact, this class can have more information, like you can use something called modifiers. If you see this is the actual syntax. Okay, here we have modifier. Modifiers tells that where can I access this class, and extend tells that who is the parent of this particular class, what is the base class for this class, and implements defines what are all the interfaces this class is going to implement. Okay, as of now we don't bother about the modifiers, superclass, and of course interfaces. Okay, but this is the actual syntax, and of course these square brackets within open closed square brackets, whatever is written, whatever is there, that is optional. Means that at the time of declaring class you may or may not use modifiers, extends, implement keywords. Okay, coming to the class, if you observe, there are two parts. One is variable declaration part, method declaration part. Variables, they resemble states of the object, whereas methods are describing the behaviors of the class. Okay, let's look at a simple example on how do we create a class. Let me open Notepad, and here I am going to define a class called demo count. Within this I have some variable like instance variable like count, and some methods like set count of something called int c. Within this count equal to c, int get count of return count. Here is the simple example of a class. Okay, we use class keyword and followed by the class name. And at the time of writing this class name, we have to follow upper camel case standard. Means that every word should start with a uppercase letter. Okay, like D and C capital here, right? Okay, let's look at what is an object. Okay, when I say object, in the real world there are several objects, right? All these objects have their own states and behaviors. If you observe, like horse, dog, or whatever, right, or even bike, if you see, they have their own states and behaviors. If you observe the bike, right, there is something called gear, accelerator, two wheels, number of gears, brakes. All these are all the states of that particular object, and behaviors are braking, accelerating, slow down, changing gears are the behaviors of that object. Even in the software, right, object is defined in this way. An object is a software bundle which encapsulate variables and methods operating on those variables. Okay, exactly like a real world object. With the help of these objects and classes, we are going to achieve modularity in programming, information hiding, that is data encapsulation, and of course with the help of these methods we are getting the benefit of reusability, right? The inside this, if there are the states, or we can say fields, and the methods are actually operating with the or operating on these fields or you know instance variables. To create the object, here is the syntax. Okay, class name followed by the object name equal to new operator, then followed by the class name with open closed parenthesis. Here we have mainly two parts. One is the declaration part. We declared obj1 is a object of so and so class, and we are going to initialize that object with some memory, no, that can be done with the help of new operator followed by the class name followed by open close parenthesis. So in the case of declaring an object, no, we are going to specify the class name and then object name, that's it. It's like data type and variable. If you observe, there is a difference between variable and object. Okay, variable holds a single type of literal, like it can hold an integer or a float or a short or something like double character, whatever. Whereas an object is actually holding instance variables and methods. Okay, so there is a huge difference. We can say simply object is more than a variable. Okay, let's say let's discuss about the initialization part. When I say initialization, when you declare a variable, that variable won't get memory. Okay, the moment when you create the memory or when you issue the instruction like new that class name open closed parenthesis, that time memory allocation happen. Okay, it takes the help of implicit explicit constructors and assign some default values for that particular object and create, right? So here is the way that object initialization, object declaration results. The moment when you declare the object is initiated with null. There is no memory or there is nothing to access. But the moment when you say new that class name with open close parenthesis, the memory allocation happen. This object has their own unique copy of account, tax rate, and of course a method called calculate tax. Okay, let's see the instance variables. Instance variables are declared within the class and of course outside the method. Okay, the variables are called as instance variables only when they declared within the class outside the method. Okay, and these objects are instance variables because whenever an object is created, for that object these variables are unique, or they are going to have their own unique copy of these variables. Okay, so when you have these instance variables, you can access these variables and of course assign values to those variables in three different ways. One is like directly you can access the value. Like in this example, I want to assign the initial count of any counter should be 10. In that moment, I can directly assign the value to the instance variable. Here, I have only one instance variable, that is count. C is not an instance variable because it is defined within the set count method. Okay, so the count variable is defined outside the methods and of course inside the class. That's why we call it as an instance variable. One way of assigning value to the instance variable is directly assigning the value. Another way is using some sort of setter methods or some sort of constructors we can do it. Okay, let's say void set count of the C. When we invoke this method, no, we are passing some value to it. That value is assigned to count. This is the another way of assigning initializing instance variables through setter or some sort of constructors. Okay, and of course apart from this we can also access with the help of object dot variable name equal to value. Okay, these are all the three different ways of accessing instance variables. Let's see something about methods. Methods are similar to functions in any other programming languages. Here in Java, no, none of the methods declared outside the class. Whatever method you declared, that is there within the class. With the help of these methods, we got a lot of benefits. We do achieve this reusability, parameterized code, top-down programming, and simplify the code. If you see the syntax of method, there is something called modifier. Modifier tells that what is the scope of accessing this method. Okay, where can I access this method? That this modifier tells. And return type, what is the return type after executing the particular method block? Okay, it could be void, int, or any data type. And name of the method followed by parameters list. And finally, throw class. Throw class usually used when this particular method behave abnormally, what exception this method has to throw. So as of now, we don't talk about this throws class and modifier. Let's see how do we define the method with the help of return type as well as method name with parameters list. Okay, these will be discussed in detail in further future classes. Okay, so return type is mandatory. It could return any void or any other value. Okay, and method name, usually practices says method name should follow some lower camel case standard. Okay, and the name of the method could be any Java identifier. Okay, and the list of arguments, coming to the list of arguments, it could be 0 or any number of arguments that you can pass in a method. Within the open closed curly braces, we are going to define statements. What statements or what block of code this particular method has to execute when it invoke. Okay, those will be written within open closed curly braces. And let's look at this method invocation. Okay, methods cannot invoke by their own. We have to invoke those methods with the help of somebody called object. With the object followed by dot followed by the method name where you can access the method. Okay, and at the time of accessing method we can pass some arguments. Okay, arguments we call it as parameters. Okay, the help of this object followed by dot and method name, when you pass those arguments, those we call it as actual arguments. Okay, let me show you what are those. Here int c is a formal parameter. Why we call it as formal parameter? It is not the actual parameter. We catch that actual parameter with the formal parameter. Okay, so let me write implementation program class impl something like public static void main string argsa. Within this I am going to create demo count object. Demo count space dc1 equal to new demo count of something like count of dc1 dot set count of something like 50 and system dot out dot println. I want to know the count. The count is dc1 dot get count of. Okay, forget save this file demo count. Let me save this demo count.java. Yeah, the count is 50. Okay, so hope everyone understand how do we access these instance variables. Three ways of accessing instance variables and invoking methods. Okay, let me do practices in this. Like yeah, I want to create one more object, demo count space dc2 equal to new demo count of. Okay, here I'm going to access the instance variable like dc2 dot count equal to, let's say, 60. Now if I print this, system dot out dot println, if you observe these three, dc1 uses set count method to set the instance variable value. dc2 directly access the count variable, and of course we assign this. dc3 is actually not using any of this, so whatever count is assigned with, by default count is assigned with 10 or 0, whatever it is, that will be printed. Let me run this program. Yeah, first time for dc1 it is 50, for dc2 object it is 60, and for dc3 it is 10. Okay, it is default. In the class itself the instance variable is assigned with 10, that's why we got it. Okay, hope everyone understood this. So when you invoke the methods, we are actually, if you observe this, when you invoke the methods, we are using the help of the object. Okay, the class object. dc1 is the object of demo count class. Using this we access set count of method. Here we are passing some variables. Here it could pass, we can pass 0 to any number of arguments. In our case we are passing one argument. This actually comes under actual argument. Okay, we call it as actual arguments. Okay, whereas here we have formal arguments. This we call it as a formal argument. Okay, and of course in Java there is no pointers concept. There is no need to think about pass by reference, only pass by value. Okay, and coming to overloading, in method overloading, two methods can have the same name but they must differ in their signature. Okay, like a method name could be same, but the number of arguments or data type of those parameters should be different. The advantage here is same kind of activities are to be performed but with the different input parameters, that is possible. If you see this example, if you want to know the maximum value or maximum number given between two or whatever arguments, right? So if you want to know the biggest number of in the a and b, okay, in the case of those two are integers, this max function this max method invoke in the case of a and b are integers. Okay, and of course if they are float, this max function, this max method will be invoked. Okay, so let me write a simple program on this. Yeah, here set count. void set count of, let's say, double D, and here I may convert it into some sort of integer and I can assign, still I can assign count equal to, let's say, int D. Okay, or else let me write another program. A comma B. Okay, void max of int A comma int B. Here I am using xy variables, let's say x comma y. A equal to x, B equal to y. Here it is float, let's say when it is float, now we have to say x equal to A, y equal to B. Yeah, let me correct this. X equal to int A, or integer dot parse int of, or else y equal to, let's say, int B. Yeah, so if A is greater than B, system dot out dot println of A is big. Else B is big. Okay, let me copy all this and put it inside. This is an example of overloading. Okay, here we have a method called maxof. The method name is same, but these two methods are different in their data type. Okay, and maybe sometimes they may differ with their number of arguments also. This is the method overloading concept. Okay.